This is lesson 5.3, graphing cubic root functions. So first, let's check that this is the right graph for the function f of x is equal to the cube root of x, which values can easily be used for x. So if we're going to take the cube root of x, the easiest values to work with would be perfect cubes. So for example, 8 is a perfect cube, so when we do f of x, when x is equal to negative 8, we get the cube root of negative 8, which is negative 2. So it's hard to see the numbers, but this is 8. So at negative 8, we can plot this point at negative 2. When x equals negative 1, the cube root of negative 1 is negative 1. So at negative 1, y is at negative 1. And 0 is 0 here. F of x, when x is 1, so the cube root of 1 is positive 1. F of x, when x is 8, the cube root of 8, which is positive 2. So in the graph above, the point 0, 0 is called the inflection point, which is the same as the center, like with cubic functions or the vertex of a quadratic. The cubic root and cubic functions are inverse functions, and it means that they're reflected across the line at y equals x. So we'll draw the line of inflection, and when y equals x, that's just a linear function. So here's the general form of a cubic root function. F of x is equal to plus or minus a times the cubic root of x minus h plus k. When a is greater than 1, there's a stretch. When it's greater than 0 but less than 1, there's a compression. And if there's a negative sign, it'll be reflected. H and k will be the inflection point. H will indicate a left or right shift, and k will indicate a shift vertically up or down. Here are some examples working with cubic root functions. So the inflection point is hk. So k is negative 2, and h is 1. So we'll plot it at 1, negative 2. That's here. And we'll go use reference points. Of 2y and 0y. So when x equals 2, when x equals 2, it's equal to 2 times the cubic root of 2 minus 1 minus 2. 2 times the cubic root of 1 minus 2 times 1 minus 2, y equals 0. And when x equals 0, g of x will equal 2 times the cubic root, that's really ugly, it's the cubic root of 0 minus 1 minus 2. 2 times negative 1 minus 2 equals negative 4. So at 0, y equals negative 4. So now we can graph this function. For this next example, we'll write our inflection point, which is hk. K is negative 1, h is negative 2. So plot at negative 2, negative 1. and we'll use the reference points of -3 and -1. So h of x, when x is equal to -3, is the cubic root of -3 plus 2 minus 1. So the cubic root of -1 minus 1 is -1 minus 1 equals -2. So at -3, y is -2. Now h of x, when x is -1, is equal to the cubic root of -1 plus 2 minus 1. That's the cubic root of 1 minus 1. It's 1 minus 1 is equal to 0. And we can pull reference points where x equals -1 and +1. So when x equals +1, we have g of x is equal to 3 times the cube root of -1 minus 5. The cube root of -1 is -1. So we have -3 minus 5, which equals to -8. So when x is equal to -1, y is equal to -8. Now when g of x equals +1, it's equal to 3 times the cubic root of 1 minus 5. 3 times the cubic root of 1 is 1 minus 5 equals 3 minus 5 is -2. So we have this shape about for this function. And you see here, there's this stretch by 3 units. Now for this one, we see that there's a negative sign here. So when there's a negative sign in front of the a value, we know that there's a reflection. A is 1/2, so there's a compression. There's a compression of 1/2. See that h is equal to 2, -2, so we shift to the left. And there's no k value, so it'll default to 0. So our inflection point is at -2, 0. It's here. So we'll pull reference points where x equals -1 and x equals -3. So when x is equal to -1, the y value will be equal to 1/2 times the cube root of -1 plus 2. 1/2 times the cube root of +1 is -1/2 times 1, which is -1/2. So we'll plot that here at -1, -1/2. And we'll do x equals -3. So when x equals -3, h of x will equal -1/2 times the cube root of -3 plus 2. -1/2 times the cube root of -1 is -1/2 times -1, which equals +1/2. So at -3, y is -1/2. And we can sketch this. These are really ugly graphs, but the math is right. So first, we'll identify our inflection point, which is here. And this is at 1, x equals 1, and y equals -4. So the inflection point is at 1, -4. We know that the inflection points are also hk. So we can have f of x is equal to the cubic root of x minus 1 minus 4. And to test if we have a value of a here, We'll find another point at 2, 2, 2, negative 2, and this point at 0, negative 6. So we can replace f of x. So we'll use this point here to find if there's a value of a. So f of x is equal to negative 2. So we have negative 2 equals the cubic root of 3. So we have x is 2 minus 1 minus 4. Actually, let's scoot this over to see if we have a value of a. We'll simplify both sides. We'll add 4 on both sides. 2 equals cubic root of 1. Divide 1 on both sides. Now we just have 2 equals a. So there is a value of a here.